Greetings, math fans. All right, so this is day one of chapter 5. And basically, the whole chapter is about polynomials. Okay, so we're going to do talking about them a little bit. We're going to kind of classify them. We're going to add and subtract. We're going to multiply. And then we're going to get into factoring. And factoring is actually a really big part. This is actually a pretty long unit. It is about a 19-day, 20-day unit. So it definitely is a big unit. All right. So you got to keep up with this stuff because this is, like I said, it just covers a lot of stuff, and it's really easy if you fall behind to not get caught up. All right. So let's get started. So here's the deal, math fans. Again, this is we'll say it's chapter 5, okay, day 1. And the first thing I want to talk about is degree. Okay, and so degree is basically what you're going to do is you're going to look at the exponents. Okay, so let's start out with a really basic one. If I have 4x to the 5th, 5 is my degree. So this is degree 5. Okay, it's really easy. 10x to the 11th power. So this is of course degree 11. So you're only looking at the exponent, So let's go down to kind of a smaller one. How about 3x squared? Of course, that's degree 2. And how about 2x, just 2x? Okay, well, you guys need to remember 2x is really 2x to the first power, right? It's to the 1 power. So they're both, that's degree 1. Okay, that's important. Okay, so if there's no exponent there, put a 1 there if you want, okay, to help you out. And then we have, if I just write the number 8, okay, 8 is actually degree 0, because it's really 8x to the 0 power, right? There's no variable there, but here's the deal. Remember what anything to the 0 power is? Do you guys agree that's equal to 1? And so that's why 8 times 1 is 8. So if there's no variable, which we call this, by the way, I'll put this in red. This is called a constant. Okay? And then of course you guys know what this is. That is called a variable, right? Which kind of makes sense. Because a variable means I can change it. I can make x is 2, 5, 10, 20, a billion, whatever. But 8 is constant. There's no, if I make a variable x equals 3, and it's still just 8, there's no variable next to it, 8 is going to stay 8. It's going to stay constant no matter what. Okay? So anyway, that's kind of what degree is. So let's actually look at a bunch of terms together. Right. So if I look at a bunch of terms, 3x to the 5th minus 2x squared plus 4. Do you guys agree this is degree 5, this one is degree 2, and this is degree 0? So when you're looking at the whole thing, what you want to do is you want to choose the highest degree. And if you choose the highest degree, that's going to be a degree for the whole thing. So choose the highest degree, which in this case is 5. So we call this a polynomial. We'll get to that in a second. Polynomial is degree 5. So we always choose the highest degree out of all the different terms, and that's going to be 5. And by the way, let's talk. Each of these is a term. That's a term, that's a term, that's a term. Okay, each one is a term. Okay, separated by the pluses and minuses. Okay, so it's separated by this minus and this plus. Always separated by a plus and a minus. Okay, so you just look at the whole thing. So let's do another one. If I said, 7x squared plus 2x to the 8th minus 3x to the 4th. Okay, what degree is this? Well, you should recognize that that's my highest number. So this is degree 8. Okay? Pretty easy. So let's kind of mix a couple of variables up now together. So what if I had, let's just do a basic one here. If I said 5x to the 6th y squared. Okay, now notice there's no adding and subtracting here. This is just multiplication. So if I want to find the degree of this term, you add the exponents of exp, I spelled it wrong, exponents, add exponents, that's bad, exponents. You add exponents of all variables in that term. I'll explain what I mean by that in a second, right? So in other words, you would say this is degree 8 because it's 6 plus 2. Okay? Degree 8. Pretty easy. So, 3x to the 7th, y, z to the 6th. Again, make sure you put that y, or it's got a 1 there. And then you'd say 7 plus 1 is 8, plus 6 is 14. So this is degree 14. Okay? Pretty easy. So let's kind of make it a big old problem here now. If I said 8x to the 7th, y to the 4th, minus 2x to the 9th, y to the 5th, plus 4x squared y to the 3rd. Each of these is a term. That's a term, that's a term, that's a term. Separated by a plus sign or a minus sign. So that's separated by this. Okay? And I think I meant to put 7 here. Okay. So anyway, what you want to do is you want to look at each one of these. So do you guys agree that this first one is 7 plus 4 is 11, so this is degree 11. And this one is 9 plus 7, which is 16, degree 16. And this is 2 plus 3 is 5, degree 5. So the degree of this whole polynomial, this is degree 16. Okay, because that's the highest degree right there. Okay, pretty easy. Okay, so that's degree. Let's talk about something called standard form. Okay, so standard form is basically you want to order the terms from highest degree to lowest degree. Okay, that's all you do. You order terms from highest degree to lowest degree. That's all you do. All right. So let me give you an example. Let's just start with just a regular variable. So if I say 2x to the, well, let me put one in order first. So 2x to the 5th plus 5x squared minus 6x plus 10. That is in standard form. It's the highest degree, which is degree 5, goes down to degree 2, goes down to degree 1, and then degree 0. Okay? So highest to lowest, that's what standard form is all about. Pretty easy. As long as you understand what the degree is, you're good to go. So let me give you an example. If I said, 2x to the 3rd minus 7x to the 4th plus 4x cubed, 4x to the 2nd power, sorry, minus 5x to the 6th. Okay, if I asked you to put that in standard form, you look at your exponents and go, oh, okay, this goes first, so it's negative 5x to the 6th, the highest exponent, and then the next one. So then it's this guy. Don't forget the signs with it, right? So then it's going to minus 7x to the 4th, and then this one plus 2x cubed, and then this one plus 4x squared. And that's in standard form. Okay? Highest degree to lowest. So let's do one kind of crazier one. How if I, let's use more variables. So if I said 2xy to the fourth minus 3x squared y to the fifth plus 2xy minus 4x squared y squared. Okay? So let's just figure out what each term is. This is, let's put a 1 there, so you know this is degree 5. This is degree 7. There's a 1 and 1, so this is degree 2, and this is 2 and 2, so this is degree 4. So we put it in order here. Okay, the order is going to be this first one here. So negative 3x squared y to the fifth. Let's use that one, then this guy. So plus 2xy to the fourth. It's good. And then the next one is this one, minus 4, this guy here, minus 4x squared y squared. Okay, cool. And then second degree, plus 2xy. We're done. That is in standard form. Okay, pretty easy. All right, what else do I want to talk about? Oh, let's just talk about number of terms, because that's actually an important concept too. So number of terms. And remember, a term is split up by a positive sign or a negative sign, plus and minus, right? Okay. So these are all called polynomials. If you guys know what poly means many. But actually, it's polynomial is one term, so one term or more. One term or more. That's a polynomial. So we have a special name. So if you actually have one term, which is like me saying 5x squared. Okay, we say that's a monomial. If I have two terms, that's like saying 2x to the third minus 5x. Okay, two terms. So that's called a binomial, like a bicycle. And then we have something three terms, like 5x to the fourth minus 2x squared plus 1. That's three terms. And just like a bicycle, you have a tricycle, right? That's a trinomial. Okay? And then if it's basically four or more terms, we literally just say it's a polynomial. There's no special word for that. Okay? So that's it. That's referring to something as number of terms by the number of terms. So let me just do a problem here. So if I do, 5x to the eighth minus 2x squared, and I can ask you two things now. I can say, tell me by number of terms, and you say, oh, they're two terms. It's a binomial. And then I say, what degree is it? You say, oh, it's degree 8. Because that's your biggest number. And it's in standard form, because it's going from biggest exponent to smallest exponent. It's really easy. Okay? So if I gave you number 18, and I asked you to tell me a little bit about it, first of all, you would say it's a monomial. Okay, it's a monomial because it's one term. And you'd also say it's degree 0, so 0 degree. It's very cold. Okay, because it's remember 18x to the 0, we don't write that, but it's really degree 0. Okay? So, and then anything, like I said, anything greater than 3, if I said 2x to the fifth minus 7x to the fourth plus 6x squared plus 5x minus 3, you would go, oh, gee, that's a lot of terms. In fact, 1, 2, 3, 4, 5 terms. It is definitely a polynomial. And the degree is 5. Okay? What's this? Let me just test you. X to the 7th, y to the 4th, z. What degree is that? Okay, you should tell me, oh, 7 plus 4 is 11, plus 1 is 12, so degree 12. Is it a monomial or binomial? Okay, you guys should say it's a monomial. Sometimes people say, oh, well, it's 3. There's no plus or minus there. If this was x to the 7th plus y to the 4th plus z, that would be a trinomial. But this is a monomial because it's 3, or it's one term, no pluses and minuses there. Okay, separating them. Okay? All right, so the last thing I want to show you guys is combining like terms. All right, so combining like terms. So here's the deal. First of all, let's talk about what a like term is. A like term is the same variable or variables and the same exponents. Okay? Got to be the same variables and it's got to be the same exponents in order for it to be a like term. So this is what I mean. If you guys have, let's start out with a really basic one. If I said 5x squared plus 3x squared, these are like terms, okay, because it's the same variable and it's the same exponent. So think about it. If I have 5x squareds and I hand you 3 more x squareds, how many x squareds? Right? How many x squareds do you have? You have 8 x squareds. Right? Most common mistake here, math fans, is people add these exponents. They say it's 8x to the 4th. And what I say to that is, boo, boo. Okay? You do not, it doesn't make sense. If you have 5x squareds and I hand you 3 more x squareds, don't you just have x squareds in your hand? You don't have x to the 4ths in your hand. There are no x to the 4ths in your hand. Okay? So what you do is you got to keep these the same. Keep the exponents the same and the variables the same. It's just saying 5 of these and 3 of these. I have 8 of these. Okay? So that's what a like term is. So let's just kind of keep, let's do another problem here. If I said, 7y to the 4th minus 3y to the 4th. You should say, oh, these are the same. So 7 minus 3, it's all you're doing really. 7 minus 3 is 4, and then it's 4y to the 4th. And that's your answer. Okay, it's pretty easy. So if you have multiple things, if I have like 3x squared plus 4x minus 7x squared minus 2x. What I always tell kids to do is you got to use colored pens or whatever, circle it, or you can do this. That's a like term with that one. And notice I'm circling the sign with it too. Okay, let's use another color. That's a like term with that one. All right, it just kind of helps kind of identify together. So now when I combine them, I'm going to actually do this in that color I circled it. You're basically saying 3 minus 7. See, it's 3x squared minus 7x squared. So you're saying 3 minus 7, which is negative 4. And if you have to use your calculator to make sure you're getting the right, adding and subtracting, then do it. Don't make a mistake on goofy stuff like that, okay? So 3 minus 7 is negative 4. And then you're going to say 4 minus 2. That's in the blue. 4 minus 2 is 2. So that, anyway, let me put this in here. It's negative 4x squared. And then the blue is plus 2x. So plus 2x. And that's my answer to this problem. Okay, that's combining like terms. So if I had other variables, let's say I had 3x squared y minus 7xy squared plus 4x squared y plus 2xy squared. So you should look to see what's the same, okay? And if you do it, you see oh, I've got an x squared y, and I have an x squared y. And then you look at the other one, oh, I have a negative 7xy squared and a 2xy squared. So those are the same. Same variables, same exponents. That means I combine those together. So I combine these two together. So 3 of those and 4 of those is 7 of those. Okay. And negative 7 of these and 2 of these is negative 5 of those. And we're done with the problem. 7x squared y minus 5xy squared, and that's it. You got it, and you're done with the problem. Okay? If I ask you what degree this was, you should say, oh, wait, let's see. The degree of this first part is, right, let's put a 1 there, and then a 1 there. This is degree 3. And what is this degree? That's degree 3. So the degree for the whole thing, since they're the same, it's 3. Okay? And it is a binomial. Okay? So just got a bunch of different things here. All right, so let's do a couple more problems here. So one last one here. Okay, we'll make this kind of a big old nasty one. If I said 3a squared plus 4a, we'll say 4a squared, minus 2ab minus 3b squared plus 5ab plus 8b squared. So what you want to do is highlight things. Also, another way to do it is you can, if you don't have any colored pencil, everyone's got their iPad, but let's say you're doing a quiz or anything, you can do this. You can say, well, I'll circle these guys here. So that's a like term, that's a like term. That's it. And then the A, B, oh, there are 2 of those, so I'll put a box or a rectangle around those. And then you got the B squared, so I'll put a triangle around that. Okay? And those are your like terms. So if I combine them together, this first one gives me 7a squared. This gives me, these two give me negative 2 plus 5 is plus 3, AB. And then these guys, 2 triangles, give me minus 3, or negative 3 plus 8 is positive 5b squared. And there you go. That's the answer. What degree is this? Well, they all have 2. This is 2, 2, and 2. So this is degree 2, and it is a trinomial because it's got 1, 2, 3 terms. Okay? So that's it, math fans. That is day 1. Again, talking about degree, talking about putting it in standard form, talking about the number of terms, binomial, monomial, trinomial, polynomial, etc. And then combining, or as the worksheet says, collecting like terms. Same thing, okay? Make sure you have the same variable and same exponent. Very, very, very important. So really quickly, because I know I mentioned it, but if you have x squared plus x, kids like to combine this together, and they like to go, oh, that's a 1 there, and so if I combine it together, I get x to the 3rd power, or 2x to the 3rd power. Boo! You can't combine these together, right? They're not like terms, so you cannot combine them together. Okay? Anyway, that's it, math fans, for day 1. You have an outstanding day. Adios. Goodbye.